Alright, so continuing, number 9. In a newspaper, the Ask Maryland section contained this question. Suppose a person was having 2 surgeries performed at the same time. If the chances of success for surgery A are 85% and the chances of success for surgery B are 90%, what is the chances that both will fail? Maryland's solution is 0.015. Is this correct? Why or why not? Okay, so first of all, we have to look and see if these two events are independent or not. So we don't know if these 2 surgeries are linked in any way. So would the outcome of surgery A have an impact on surgery B? And so you can't assume that these 2 surgeries are 2 totally separate surgeries. And remember, in order to use your multiplication rule, it has to be independent. So in this case, you cannot assume independence, and therefore you can't say that you multiply those 2 probabilities to say that the probability of both failing is 0.015. Okay, number 10. A store receives 75% of its light bulbs from company A and the rest from company B. Suppose that 3% of the light bulbs from company A are broken and only 2% of the bulbs from company B are broken. What is the probability a received light bulb is broken? So you have 2 events here. Basically, company A, company B, and then you have whether they're broken or not broken. So here's company A, company B. The rest, again, company B are broken, so there's your 75% from company A. And then of company A's, 3% are broken, which means 97% are not, and 2% from company B are broken, which means 98% are not. So you're looking for the probability that they are broken. So you have to take both of the branches in the tree diagram that give you a result of broken. So 0.75 times 0.3 from company A, and then 0.25 plus times 0.02 from company B. Multiply and add, you get 0.03. Okay, for number 11, suppose that when you get dressed in the morning you have 4 pairs of jeans to choose from, 3 shirts and 2 pairs of shirts. Assuming all match, how many possible outfits are you there? This is just simple counting principle, 4 times 3 times 2, so you have 24 outfits. Number 12, a manufacturer of cameras knows that a shipment of 30 cameras sent to a store contains 6 defective cameras. The manufacturer also knows that the store will choose 2 of the cameras at random, test them, and accept the shipment if neither is defective. So, what is the probability that the first camera selected will be defective? So, you're picking a camera. Again, there are 30 of them, and 6 are defective. So your first probability is 6 out of 30, which is 1/5. So now, given that the first pass inspection, what is the probability that the second camera chosen will fail the inspection? So in this case, you're doing what is the probability of defective given that the first one passed. So again, you want to do the probability of defective and pass divided by the probability of just pass. Okay? So the probability of defective and pass so you could go through and calculate this, but really you're just looking for, knowing that the first one did pass, how many do you still have left that are defective and how many cameras overall do you have? And in this case, you can simplify this a lot. You don't have to go through all of this work to do it. It's really just 6 out of 29, which is 21.221. Okay? What is the probability that the shipment will be accepted? So in this case, you want the first one to pass and you want the second one to pass. So 24 are good out of 30 times then 23 out of 29 because you've already chosen one that's good. And the answer would be 0.63. Okay, number 13. We played craps to start this unit. That's the dice game. Basically, 7 or 11 on the first roll, you win. If the roller shoots 2, 3, or 12 on the first roll, they lose. So what is the probability that the shooter will win on the first roll? Meaning that they get a 7 or an 11 on the first roll. So the probability of a 7 or an 11 is 6 out of 36 for a 7, 2 out of 36 for for an 11, and therefore you get 8 out of 36, which is 0.22. The easiest way, again, to do this is through that tree diagram that we first originally drew. So the 1, 2, 3, 4, 5, 6, and again, you have to know your sums of the two dice. So 1, 2, 3, 4, 5, 6. Okay, so the number of ways you can get a 7, there's 1 here, and then you can go through and list the rest. And then for an 11, there's really only 2 ways. Add them together, you get 0.22. There's no overlap, there's no way to get a 7 and an 11 at the same time, so therefore there's nothing to subtract. What about the shooter losing on the first roll? The only way to lose if he shoots a 2, 3, or 12, so that's a probability of getting a 2, 3, or 12. Probability of getting a 2 is 1 out of 36, a 3 is 2 out of 36, and a 12 is 1 out of 36, so you have a lower chance of losing on your first roll than you do of winning. For number 14, if 10 students enter a classroom that has 4 vacant seats, in how many ways can they be seated? So this is seat 1, seat 2, seat 3, seat 4. So if 10 people sit, then 9 people sit, then 8, then 7, 5,040 ways. For number 15, suppose that the probability of E is equal to 0.76, the probability of F is 0.45, and the intersection of E and F is 0.32. Therefore, you know that these are not disjoint events because there is an overlap. And you will have to subtract that out if you do any of the ORs. And the first thing that you do is what is the probability of E or F? So there's E or F, which is 0.76 plus 0.45. Subtract out the overlap, you get 0.89. The complement of E and the complement of F, and then the intersection of the two, that's basically 1 minus the probability of E union F. We talked about that in class. Kind of with that at least notation. So 1 minus 0.89, which is 0.11. And what is the probability of F intersection the complement of E? So you take the complement of E and the probability of F and add them, or you can subtract out the probability of E and you get 0.13. Okay, suppose the probability of A is 0.59, the probability of B given A is 0.45. What is the probability of A intersection B? You should note that all 3 of these elements are included in that formula for the given. So therefore, just plug in the things you know, solve for the P of A and B, and you get X is about 0.27. Okay, for number 17, a school nurse reports that 2 patients, A and B, have been admitted to the health room and have contracted senioritis. Suppose our experiment consists of observing whether the patients fail or pass as a result of the disease. The simple events and probabilities of their occurrence are shown below. So here's both. A passes, B fails, A fails, B passes, and both fail. So what is the probability that both patients pass? And again, that's given to you right here, 0.81. At least 1 patient fails. So that would be A fails, B fails, or both fail. So then there's A fail, B fail, both fail, add them together, get 0.19. And exactly 1 patient passes. So this is not exactly 1, this is not exactly 1, but both of these are exactly 1. Add them together, you get 0.18. For number 18, a state energy agency mailed questionnaires on energy conservation to 1,000 homeowners in the state capital. 500 questionnaires were returned. Suppose an experiment consists of randomly selecting one of the questionnaires. Consider the events. A, the home is constructed of brick, the home is more than 30, or the home is heated with oil. So now, again, using the union, intersection, and complements, that would be union, intersection, complements would be to the C power. So a home is more than 30 years old and it's heated with oil. So there's B, intersection, C. More than 30 and heated with oil. The home is not constructed with brick. Well, A is constructed with brick, so therefore A to the power of C, or A to the C, would be considered the complement. The home is heated with oil or is more than 30, heated with oil or more than 30. The home is constructed of brick and is not heated of oil, so constructed of brick, intersection, the complement of C. Number 19, 6 people apply for 2 identical positions in a company. 4 are minority applicants and the remainder are non-minority. Define the following events. Okay, both persons selected are non-minority candidates. Both persons selected are minority candidates. At least one of the persons selected is a minority candidate, and minority candidate number 1 is selected. So the probability of A, you have 2 out of 6 times 1 out of 5 because you've already selected somebody, because you're doing non-minority. Both are selected, so you have 4, and then there's 3 left out of 6, so again, multiply. At least one person, that means both non-minority and the complement of that, so 1 minus 1/15, which is 0.93. And then minority candidate number 1 is selected. So therefore, again, you're kind of looking at a tree diagram effect, so which of them gives you the results of minority candidate number 1. So 1/6 times 5/5 plus 5/6 times 1/5, which is 1/3. You'll find the rest of the videos in my rest of the questions in the last video.